So for example number 3, what we're going to do is they say write a polynomial function with the minimum degree in the standard form with real coefficients whose zeros include x equals 1, x equals 1, plus 2i. Oh man, that threw me off for a second. Plus 2i, and then x equals 1 minus I. Now, we got to remember that when we do this, that the conjugate, even though they tell us this, the conjugate always comes with us. So another one is x minus 2i, and another one is 1 plus I. So those are all the solutions. We can't ignore those. Does that make sense? We can't ignore those. And so when we can't ignore those, they've given us 3 solutions, but in reality, how many roots or zeros are there? There's 5. So what degree polynomial would you expect this to be? How many x equals statements do you see up there? 5. Now they only gave us the first 3, but remember, complex numbers, they travel in pairs, and those pairs are conjugates. So now what I need to do is I say f of x equals, and I'm going to take each one of these and set them equal to 0, which will give me x equals negative 1. Right? Because if I take this and set it equal to 0, I'll say x minus 1 equals 0. I said it wrong, but I wrote it down right. And so if I do that with each one of these, I'm going to change the signs of the solution. So I'm going to say x minus 1 plus 2i, x minus 1 minus 2i. Okay, you guys with me so far? You see what I'm doing? X minus 1 minus I times x minus 1 plus I. Try not to skip this step. Or, I mean, you could, but it's going to throw you off. Just make sure that if you skip the step that you do it right. So I've got x minus 1, and then x, when I distribute the 1 through the parentheses, I get x minus 1 minus 2i times the quantity x minus 1 plus 2i, and then times the quantity x minus 1 plus I, and then x minus 1 minus I. Now, probably the best thing to do would be to multiply the complex numbers first and then do this one real solution at the end. So I'm going to pick these two. I'm going to say x minus 1 minus 2i times the quantity x minus 1 plus 2i. So I get x squared minus 1x minus 2ix. Over here I get minus 1x. Over here I get plus 1. And I get negative 2 or positive 2i. Down here I get 2x. Then I get, oh, this has got an I on it, right? So that's 2i. Down here I get a negative 2i. And then this becomes a negative 4i squared. And so Mr. Adams is trying to think and write at the same time, but this should cancel with this, and it does. This cancels with this, and it does. And so what I should be left with is some x squared. I shouldn't have any more complex numbers after I multiply the conjugates. And I don't think I do. So all this stuff is x squared minus 2x, because I'm combining like terms. I've got minus 1x and minus 1x. Okay. And then I've got plus 1. Now what is negative 4 times I squared? I squared is negative 1, so what's negative 4 times negative 1? Positive 4. So 4 plus 1 is 5. I'm going to drop this x minus 1 down here. And so the only thing I have left to do is multiply these. So I've got x minus 1 plus I, x minus 1 minus I got x squared minus 1x, ix minus x plus 1, 1 I minus ix minus I and negative I squared. So again, I'm going to have this cancels with this cancels with this. I have like terms here. And so this should equal x squared minus 2x. Oops, I shouldn't have closed my parentheses. Minus I squared. I squared is negative 1, so this is a positive 1. So positive 1 plus 1 is plus 2. So we'll try to change that to a plus sign, plus 2. Okay? Does that make sense? Am I done yet? No, I'm far from done. What I need to do now is I need to say f of x is equal to, and then I need to FOIL these. So I'm going to take the big ones first and then multiply it by this at the end. So I'm going to say x squared minus 2x plus 5 times the quantity x squared minus 2x minus or plus 2 so I've got x squared times x squared is x to the 4th minus 2x cubed, 5x squared, negative 2x cubed, positive 4x squared, minus 10x. You guys play along at home to make sure that I'm not making any mistakes. Minus 4x and then positive 10. Times whatever this is, right? So that gives me, if we look at the like terms, these are like terms. These are like terms. And these are like terms. So I'm going to combine all my like terms, see what I get. And so this becomes x to the 4th minus 4x cubed. 2 plus 4 is 6 plus 5 is 11. So we have positive 11x squared. And then we have minus 14x plus 10. Now Mr. Adams is really going to double check this and make sure that I didn't make any mistakes, because at the end of this I want to make sure you know, because it's a lot of work, and if I made one mistake at the beginning it'll screw up the rest of the problem. Okay, so now it's all this stuff times x minus 1, but before I move forward I just want to double check. It looks good. Do you guys see any mistakes? Alright, so I'm going to say x to the 4th. So all this stuff equals f of x. So x to the 4th minus 4x cubed plus 11x squared minus 14x plus 10 times the quantity x minus 1. So this is x to the 5th minus 4x to the 4th plus 11x cubed minus 14x squared plus 10x. Then this is just the negative of everything here, right? Oh, it's negative 10. That's the opposite, right? Is that right so far? So now if I combine like terms, my f of x should be, now remember, if both polynomials are written in descending order, the diagonals are always going to be the like terms. So I should have x to the 5th minus 5x to the fourth plus 15x cubed minus 25x squared plus 24x minus 10. That's our answer. And that's the answer in the book, by the way. Any questions on that? Yes.